Okay, so the heart, okay, most of us think of the heart as a single pump, but reality is not. It's actually two pumps. Okay, you have one on the right side, one on the left side. Okay, the one on the right side is part of the pulmonary circuit. Okay, so you use up all the oxygen in the bloodstream and it goes back to the heart. It goes to the right side. The right side receives the oxygen poor blood from the body, and then it pumps it to the lungs. Okay, for now, the lungs magically pick up oxygen and then takes it back to the heart. Now it goes to the left side. The left side is the systemic circuit, and that takes the oxygen-rich blood from the lungs now and pumps it to the rest of the body. And then the body uses up all the oxygen and then takes the blood back to the right side, the pulmonary circuit. Okay, so that is the double pump. Okay, the heart has two atria and two ventricles. So it has four chambers. Okay, atria or atrium for singular is a chamber for receiving blood. Okay, and atria is also a chamber for receiving guests inside the house. So like it's when blood enters, okay, it always enters into an atria. Okay, from the atria, it always goes to the ventricle. Okay, the ventricle pumps the blood. Okay, actually physically pumps the blood. Okay, so here you can see on the right side, okay, is the pulmonary circuit. On the left side is the systemic circuit. Okay. All right, I'll point out the heart doesn't actually look quite like this. The left side is a lot bigger than the right side, and I'll explain why in a little bit. Okay, the heart is typically 250 to 350 grams, so a little bit less than a pound. It's the largest organ in the mediastinum. Okay, it's located between the lungs. So here is the heart. Okay, there's a couple of parts of the heart that you have to identify, starting with that. That's the apex. Okay, this broad surface that's attached to the diaphragm there. Okay, that's the base of the heart. Okay, the four corners of the heart will skip. Okay, you'll learn those when you learn to take when you measure, like when you listen for heartbeats. Okay, you do that in physio. Okay, the pericardium. Okay, is the layer surrounding the heart. So pericardial sac. You guys learned already. Okay, so pericardium has two primary layers: a fibrous pericardium and a serous pericardium. Okay. The fibrous pericardium, okay, makes up the pericardial cavity. It's outside the pericardial cavity. It is what physically protects the heart and anchors the heart in. Okay, it prevents the pericardial cavity. The reason why it's in a cavity is you prevent the ventricles from overexpanding. Okay, and if there's too much fluid in here, there's too much pressure on the heart, and the heart goes in the cardiac tamponade. So the pressure inside prevents the ventricles from expanding too much, but you don't want too much pressure because then the ventricles won't expand enough. Okay. Okay, the epicardium is the visceral layer of the serous pericardium. The epicardium is literally on the surface of the heart itself. The myocardium is the muscle layer. Like most of the heart is actually like when you feel a heart and play with the heart, most of what you're touching, okay, or most of the mass on the heart is the myocardium. You're actually mostly touching epicardium on the surface or the endocardium on the inner surface, but everything in between is the muscle. Okay. The endocardium is an endothelium lying a layer of connective tissue. It lies in the internal walls of the heart. Okay. The endocardium has a very smooth, very thin layer on the inside wall of the heart. Okay. At this part of the heart, the last thing you want is it to be not slippery and slick and to be rough. If it's rough, you can rub blood cells against it and it can cause clots. Okay, cause damage and can cause clots. So what you want is a super slick, super smooth. Okay, if you look at it, live heart, if you look at it, it should be super slick. And it's going to be continuous with the blood vessel tubing. Okay. So the chambers, okay, you have a left and right atria, the superior chambers, left and right ventricles, inferior chambers. There's a division between the left and right sides, and that is the septum, the wall. Septum literally means wall. Okay. So okay. So if you cut into the wall, there's a wall right here. The thicker layer is the interventricular septum. This the wall between ventricles. There's another one here called the interatrial septum. Okay, you can see part of it right here where it says fossa ovalis. That's the wall right there. Okay. All right. Okay, so let's then go through the external markings of the heart. There are 3 sulcuses or grooves on the heart that you have to know: the coronary sulcus, the intraventricular sulcus, and the posterior intraventricular sulcus. Okay, so here's the actual heart. You can see that right there. There is a deep groove that separates the purple thing, which is the atria, from the red and white thing, which is the ventricle. That is the coronary sulcus, or coronal sulcus. Okay, that groove is where the coronary arteries and coronary veins run. Okay, so there's that. Now we'll rotate this a little bit. Okay, so here's the front of the heart. See this line right here? Okay, that's covered in fat. This groove right here, the front of the heart. So anterior, in between the ventricles, interventricular sulcus. And if I rotate the heart some more, that's not a good image. So let me show you the posterior. So the posterior, okay, interventricular sulcus. Okay, let's start with the right atrium. Okay, so the right atrium forms the right border of the heart. Okay, it receives oxygen-poor blood from 3 blood vessels. Okay, so there's 3 ways to get into the right atrium: superior vena cava, inferior vena cava, coronary sinus. Okay, superior vena cava takes all the blood from above the heart. Inferior vena cava takes all the blood from below the heart. Okay, the coronary sinus takes the blood from the heart itself. Okay, it drains all of that blood into the right atrium. Okay, you don't have to identify the pectinate muscles or the crista terminalis. Okay, you do have to identify the fossa ovalis. Okay, so let me show you what that is. Okay, it is that right there. Okay, keep moving slides today. Okay, that little groove. Okay, that fossa ovalis. Fossa is a shallow trench. Ovalis, for ovale, is a dent in the wall between the left and right atria. That thing used to be a hole called the foramen ovale. Okay, when you are in utero, okay, that thing was a hole because the blood flow had to flow differently when you're a fetus, because as a fetus, you're getting your oxygen from your mother and not from your lungs. You're actually getting your oxygen through the inferior vena cava. Okay, but as soon as you're born, that all changes when you start breathing. When you start breathing, and it, cut the umbilical cord, you are getting your oxygen from your lungs. So that has to seal right away. Okay, usually seals. It closes within the first half hour of your life, and then it eventually seals. But for some people, it doesn't seal and leaves a tiny little hole. Okay, and that eventually either seals over time or you need surgery to fix it. Okay, and that's called a interatrial defect. Okay. So yeah, my oldest daughter had that, but that eventually closed without problem. Okay, so on to the right ventricle. Okay, the right ventricle is right here. Okay, so blood is going to come in here, and then it is going to come into this chamber. Okay, to do that, it has to pass this valve. Okay, this valve is called the tricuspid valve because it has 3 flaps. Okay, so tricuspid. Okay, and so let me show you how these flaps work. So this is a tricuspid valve. The tricuspid valve attaches to these little strings. Okay, these little strings are called the chordae tendineae. Okay, these little strings, they keep the valve shut. Okay, they prevent the valve from flipping open backwards. Okay, and they're attached to these little muscles, okay, called the papillary muscles. Okay, the other term that you have to know is the trabeculate carne. The trabeculate carne are the little strips of meat. That's what trabeculate carne actually means on the inner walls here, like here, here, here. They don't place the arrows on a great portion here. These are trabeculate carne. It's not wrong. It's just like easier to point them out here and here and there. Okay. Okay. Uh, what else? Okay. So, carne, papillary muscles, carne, tendinae. Okay. So now this is going to contract, and remember, ventricles shoot blood out of the heart. Okay. So they shoot blood out of the heart. So I'm here. I can't go back up because this valve will close. So I go up this way. Okay. So let me draw blood flow. So I start here, I go that way, and then I go that way. So actually, let me change color. Because this is deoxygenated blood. So I start here, I go into here, right? Now this valve will close and I can't go back up this way. So valves, okay, basically prevents backflow. Okay, so I can't go back, so I can only go forward. So instead of going back, I'm going to go that way. Okay, so I'm gonna go into this tube right here. This tube is called the pulmonary trunk. Okay, but before I get into the pulmonary trunk, I'm going to go past these valves right here. Okay, and these valves right here are called the pulmonary valve. Okay, because I'm going to my lungs, I'm going to my pulmonary system, so pulmonary valves. Okay, the full name for those valves are actually the pulmonary semi-lunar valves. I'll explain why they're called semi-lunar valves in a second. Okay, but now in the pulmonary trunk. From the pulmonary trunk, I will split left and right and go into either the left pulmonary artery or the right pulmonary artery. But I go to my left lung, I'm going left pulmonary artery, right lung, right pulmonary artery. Okay, so there is something that I want you guys to delete from your brains. Okay, I'm sure your well-meaning high school biology teachers taught you somewhere along the way that arteries carry oxygenated blood and veins carry deoxygenated blood. That is literally not true. Okay, these pulmonary arteries are arteries, but they carry deoxygenated blood. Okay, there are other things that do other arteries that do that as well. Okay, so arteries carry blood away from the heart. Okay, pulmonary artery carrying blood away from the heart. Veins carry blood toward the heart. So pulmonary veins carry blood toward the heart, even though they're oxygenated. Okay, so arteries away from heart, veins toward the heart. That is literally the meaning of what those words mean anyway. Okay. Okay. Um, so let me show you the coronary sinus. The coronary sinus is here, and it opens up into a little hole. Okay, there. Okay. Okay. Ah, yeah, right there is the coronary sinus. Okay. Um, okay. Okay, so now I'm taking blood back from the heart. The blood from the heart comes into the left atrium, okay, through the pulmonary veins, okay, and now we have another valve. This valve right here is called the mitral valve or the bicuspid valve, okay. Mitral literally refers to a mitre. Mitre is, if you're Catholic, it's the fancy like triangular hat that popes and bishops wear during the more holy like Catholic holidays. I'm not Catholic, so sorry. Okay. The bicuspid valve means it has two flaps. Okay, the easy way to remember between tricuspid and bicuspid. Okay, you try before you buy, and therefore you go through the tricuspid before you go through the bicuspid. Okay, so now I'm going to talk about blood flow from this side, and we'll switch to red because red. Now I'm oxygenated. So I'm going to go here. Okay, into the left atrium, and from the left atrium, I'm going to the left ventricle. okay? And from the left ventricle, I'm gonna go out that valve, and that is the aortic valve right here into the aorta. Okay, so that is the blood flow from the right or from the left side out of the heart. Okay, and from the aorta, I'm gonna go everywhere else. Okay. Okay. So here you can see the valves right here. Okay. These two, the mitral, okay, the tricuspid, okay. These two are the semilunar valves. So you can see aortic valve, pulmonary valve. These are they're semilunar in shape. So semilunar in what's what we call them. Okay. All right. So you can see blood flow in here, and you can see blood flow out there. And you can see, like this is a really cool picture, because you can see exactly what these chordae tendineae and papillary muscles actually do. They prevent backflow. Okay. Okay. So now you push the blood up through the semilunar valves. Okay. And then once you do that, these valves again close to prevent backflow. Okay. All right. So your heart sounds. Okay. Your heart sounds go 1, 2, 2, 2. Okay. Bum 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 lub dub lub dub lub dub. Okay. The first sound is the lub. Okay. First of all, your heartbeat is not actually the sound of your heart beating. Okay. It is actually the sound of the valves closing. Okay. The first sound, the lub, is the sound of the AV valves closing. The second sound, the dub, is the semilunar valves closing. Okay. So lub and then dub, because blood goes from atrium to ventricles, and then from ventricles out to where they need to go. Okay. Okay. This we'll skip. You'll learn that during physio. Okay. But basically, the 4 chambers of the heart. Okay. So, beginning with oxygen poor blood in the superior inferior vena cava. Okay. The blood drop passes through all the structures sequentially. Okay. So each chamber has to have the same blood volume. Okay. Atrium right together, ventricle right together. Okay. So make sure you understand this picture or this slide. Okay. Because this is literally what you'll be tested on for the lecture quiz. Okay. So superior vena cava, inferior vena cava, coronary sinus. Okay. So these 3 tubes enter into the heart, right atrium, right there. So now the blood is in the right atrium. From the right atrium, it has to go through the tricuspid, okay, into the right ventricle. Okay? When the right ventricle contracts, it goes past the pulmonary semilunar valve into the pulmonary trunk. Okay? A trunk is a short tube that will split. Okay? Okay. This trunk right here splits into left and right sides. Okay, So right pulmonary artery, left pulmonary artery, they go to the capillaries, they pick up oxygen, then they go to the lungs and pick up oxygen, okay? And then they come back into the pulmonary veins. The pulmonary veins empty into the left atrium. And from the left atrium, they empty past the mitral valve into the left ventricle. And from the left ventricle, they go through the aortic semilunar valve into the aorta. Okay, so make sure you understand this, and this will be a major portion of the exam, or not the exam. Well, actually, it will be a major portion of the exam as well, but it's going to be a major portion of your lab lecture quiz. Okay. Your heartbeat is about 70 to 80 beats per minute at rest. For you guys, since you guys are young and healthy, it's probably a little bit less than that. Okay. If you're super healthy, super athletic and stuff, your heartbeat can even be lower than that. It can be like 40s and 50s. Okay. They have athletes have bigger hearts and strong hearts, and therefore they don't need as much pumping. So one pump can do more, so they have less pumping. Okay. The walls differ in thickness. Okay. Okay. First of all, the atria literally is above the ventricles, and so they literally have to pump blood from the atria to the ventricles, which is an inch away, and they're literally on top of the ventricles. So you don't really need them to actually pump unless you're actually upside down. If they don't pump, you won't die. The blood goes from the atria to the ventricles pretty much all by itself due to gravity. Okay. The ventricles do pump, and therefore they have thicker walls. Okay, they need actual muscles to pump. Okay, the systemic circuit is much bigger than the pulmonary circuit. Okay, the pulmonary circuit, I go from my heart to my lungs back to the heart. For the systemic circuit, I go from my heart against gravity to the top of my head and back, or I go from my heart down to my toes and back. Okay. Okay. So the left ventricle is 3 times thicker than the right ventricle. Okay, it is thicker, it is stronger, it exerts more pumping force. It is not a bigger hole. Okay, this hole and this hole is the same size. They have the same volume. This is just more muscle. Okay, we'll skip the cardiac muscle thing. The one thing that I would like to point out about cardiac muscle. Okay, I said, if you see these, it's cardiac muscle. And the reason why I know it's cardiac muscle and why these things are important, right? It's because they contain a whole bunch of gap junctions. Okay, the intercalated disc control a whole bunch of gap junctions. So when the signal comes, I can move the signal from one cell to the next cell to the next cell without any disturbance. Okay, and almost immediately. Okay. The next thing I want you guys to make sure you understand is the conducting signal throughout the heart. Okay. Okay. Your heart beats on its own. Okay. It doesn't need your brain to tell you to beat. It's actually pretty cool. So, for those of you guys who are older than I am, I'm sure one of the videos or movies that you guys watched was Indiana Jones and the Temple of Doom. And somewhere in the middle of the movie, the evil shaman or whatever his name is, reaches into the person's chest rips his heart out, and his heart is like literally beating in his head. Okay, and that really cool scene always stuck with me. But the heart is beating on its own, and that is what it's supposed to do. Okay, it generates its own electrical current to cause heartbeat. Okay, we can tinker with the current, we can make it faster and we can make it slower. We cannot like make it stop. Okay. Okay, so here, this little patch here is the SA node. Okay, the SA node is known as also known as the pacemaker of the heart. So when you have an artificial pacemaker put in, the artificial pacemaker is taking the place of the real pacemaker. Okay, which is the SA node. Okay, the SA node will beat, will it inherently set itself off. It usually sets itself off once, or sorry, 100 times a minute. Okay, so we're constantly slowing it down, and that is one of the functions of the vagus nerve. Okay, so the SA node generates an impulse. That impulse causes the atria to contract and also triggers the AV node, but it takes a 0.1 second stop at the AV node. And that 0.1 second is really, really important because that 0.1 second allows the blood from the atria to flow into the ventricles. Okay, so now from the AV node, you go to the AV bundle. The AV bundle goes down to the bundle branches, and then it goes to the Purkinje fibers. Okay, the Purkinje fibers then contract the ventricles and shoot the blood out of the system, out of the either the pulmonary trunk or the aorta here. Okay. Okay. The Purkinje fiber is also known as the subendocardial conducting network. Okay. 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 Coronary arteries. Okay. Supply blood to the muscular walls and tissues of the heart. Okay. The aorta is what takes the blood out of the heart, but from the very base of the aorta, okay, come the coronary arteries. Okay, so left coronary artery right here, right coronary artery right there. Okay, the coronary arteries supply the blood back to the heart. Okay. Okay, so the right coronary artery, left coronary artery, okay, they run in the coronary sulcus. Okay, the left coronary artery branches into the anterior interventricular artery, okay, otherwise known as the LAD. Okay, so the reason why these are important, okay, so that's the left coronary artery right there. It brings it down to the circumflex and the LAD right there. Okay. These are the vessels that are damaged and you need when they go bypass. That's what they're bypassing. Okay, the coronary bypass. Those are the arteries that are usually bypassing. Okay. Okay, but you're only really responsible for right and left coronary arteries. Okay. Okay. The coronary sinus, okay, returns the blood from the heart into the right atrium. Okay. Okay. Coronary artery disease, atherosclerosis, fatty deposits, okay, that block the flow of blood. Angina pectoralis, pectoris, chest pain, myocardial infarction is actually what a heart attack is. Okay. Ischemia, there's no pain or warning. Like what if you block one of the arteries to the heart, you can get massive amounts of damage without actual pain or warning. Okay. Heart failure is a progressive weakening of the heart where it can't meet the body's demand for oxygen. In the case of congestive heart failure, the heart enlarges and that decreases pumping efficiency. Okay. All right. Arrhythmias are normal variation from normal heart rhythm. Okay. So there's AFib and VFib, atrial fibrillation, ventral fibrillation. Ventral fibrillation is by far the more dangerous one. It can cause common cardiac arrest. This is the one where they actually should shock you. They do that in TV shows a lot, and it's cool to like watch. It's just dramatic, but you know it's not all that useful. Okay, and then AFib, atrial fibrillation, okay, is the screwing up of the atria. Okay, that really isn't as dangerous as VFib, but it can lead to strokes. It can lead to clot formation because when these are going off like randomly, they can cause blood to clot. Okay. All right. Birth defects. Okay, so both birth defects. One of the big things about the heart is the birth defects in the heart. Okay. The most common one is a VSD or ventricular septal defect, in which there's a blockage of the heart right here, or sorry, there's a hole between the ventricles of the heart, and you have to actually either go in and repair it. I had this when I was a child, so that was repaired. Okay. Okay, so the other one, the transposition of the great vessels. The great vessels refer to the pulmonary trunk and the aorta. Okay, where they're switched, and now these become circular loops. Like what stays in the aorta stays in the systemic circuit, and this is the pulmonary circuit, and now they're completely apart from one another. They don't cross. That is a major problem. That will kill you if that happens, right? So they have to repair that. They have to switch them before you're disconnected from placenta. Okay. All right. So there you go. All right. Hopefully that makes sense to you guys. We'll of course go over this in lecture. So.